Hello. Okay, so I think we can start the class, na? Okay, so in this subject, as you know that the name of the subject itself is structural analysis. Okay, so in this subject we will be basically dealing with RCC structures. RCC means reinforced cement concrete structures. Okay, so first of all, can you tell me what do you mean by concrete? Please unmute yourself and tell me the answer. If anyone knows what is concrete, please unmute yourself and tell me.
Sir, mixture of
Mixture of
sand, cement,
sand, cement, and
aggregate,
aggregate, and
water.
yes, water. Okay, so water. Can you tell me how much amount of water we have to add, or we can add any amount of water? Hello. Okay, you can turn on your video also. Huh? You can turn on your video because I am recording the class. Okay, I am recording the class, so you unmute yourself as well as you turn on your video also, so that I can see your faces. Hello. Okay, so I asked you a question, can you add any amount of water to concrete?
No, sir.
So is there any provision, or is there any formula or anything by which we can govern that water amount of water?
In ratio of
How much water we can add?
Sir,
Yes.
the amount of water, like, it depends upon how much concrete we are mixing, no, for a particular work.
How much concrete you will prepare
Yeah,
depend on that.
yeah, like how much cement, chips, balu, these things we are mixing. According to that, we will add water.
Okay.
Yes, we can add random quantity of water, no.
Okay. So, anyone have any other answer? Anyone?
Hello, sir.
Yes.
I think we have to find first the standard consistency of the cement, sir.
Standard consistency. Okay. So, what is consistency?
Uh, the I think standard consistency of cement is the amount of water we have to be add for the cement to have maximum strength
Okay.
and durability.
Okay. So, water content it is based on the quantity of cement. Okay. So, there is a term. I think you have heard the term water cement ratio. Is it? Did you hear the term water cement ratio?
No, sir.
No. Okay. Okay.
No.
So, water content depends upon the quantity of cement. Okay, how much cement you are adding for getting a particular amount of concrete. So based on that we have to select the amount of water. Okay, so So do you have pen and paper with you?
Yes, sir.
Okay, so you can write down one thing. For a workable concrete, maximum water cement ratio can be 0.8.
Sir, once again, please.
For a workable concrete means if you are making a concrete and if it is not workable means if you can't use that concrete then so it's of no use, no? So
Mm.
for any concrete the maximum amount of water cement ratio, maximum value of water cement ratio is 0.8. Okay, 0.8 maximum value. But in general the water cement ratio is 0.5 to 0.6 for any concrete. Okay, for a good quality concrete, for a good workable concrete, water cement ratio is generally 0.5 to 0.6.
Liter. Sir, in liter, right?
No, it is a ratio only, it doesn't have any unit.
Oh, okay, sir.
Can you repeat again?
For a good workable concrete, maximum water cement ratio is 0.8. Okay, and in general, okay, whatever concrete we can see in the daily construction, normally the value of water cement ratio is 0.5 to 0.6.
Ano, for news, saka may
What? Okay, so now you can ask me one question, that which unit we have to measure the cement or sand or aggregate, whether you will measure it in terms of weight or in terms of volume. You tell me.
Sir, volume.
And if you measure in terms of weight, then can we measure in terms of weight also? You tell me that. Weight or volume? You read these things. I think you read these things about concrete, in last semesters. Yes or no?
Sir, I didn't understand your question.
Means the say if you want to prepare a particular grade of concrete, okay. So for that concrete
Yes,
you have to
sir.
measure cement, sand, aggregate, everything you have to measure, na? So
Mm.
measure those things in terms of weight or in terms of volume.
Sir, wait.
Weight, okay. Okay, so why not volume? Why not volume?
Uh,
Volume. So because it has container and volume doesn't have.
It has container. What has container?
I mean,
No, we normally accurate measure, for accurate measurement we should measure in terms of weight, because yeah, in terms of weight, because our cement volume gets changed with time. Okay, because our cement, if you keep your cement exposed to atmosphere, then what will happen? It extract water from atmosphere. So in that case, the volume changes. Okay, the volume of
yes, sir.
it changes with temperature, means you can say temperature also it changes. So if you keep open your cement content, then it will take some amount of moisture from the atmosphere, and in that case the volume increases. So for accurate result, we have to measure these ingredients in terms of volume. But in actual practice, if you see any construction site, they will always measure in terms of volume only, because they don't in practical things they don't take this weighing machine with them, is it? So they just take a container, and they just say, if they take one full amount of, say, if they have a bowl, okay, if they have a simple container with them, so for preparing any concrete, they just fill up that bowl. Say if they take one bowl of cement, they will take two bowl of sand. They might take three bowl of aggregate. Okay, I think you have seen that. In actual practice, these laborers, they don't measure these ingredients in terms of weight. Okay, because of the absence of weighing machine. Okay, I think you have seen in construction site.
Yeah, sir. Sir,
Yeah,
but is this are they doing accurately?
yeah, almost accurate.
If they are doing
But for exact result, we should measure this in terms of weight. Okay, but
okay,
in
okay.
practical condition, say it will change by 1 or 2%. Strength will change 1 or 2%. Okay, 1% strength
Okay.
will get difference. You will get 1% or 2% difference. But for getting the exact result, we should always take this measurements in terms of weight. Okay, so there is a term known as batching. Okay, batching, batching. You should write that. Okay, batching. You write that.
Sir, once again, spelling.
Batching,
So
batching.
can you repeat? Um,
Batching, batching. I can write down the term in chat box. I think all of you can see,
uh,
na?
yes, sir.
Yeah,
Yes, sir.
yes, yes, yes.
Yeah, that batching.
Okay, thank you, sir.
Oh,
Okay, so you can write down batching of concrete means batching of concrete means measuring different ingredients. Measuring different ingredients of concrete measuring different ingredients of concrete before mixing it before mixing it before mixing it before mixing it in terms of in terms of weight or volume. Okay, so next you can write, when this measurement is done when this measurement is done on the basis of volume, on the basis of volume, we call it as volume batching. We call it as volume batching. Okay, wait 1 minute. Okay, 1 minute. Okay. Okay. So did you write batching, everyone?
Yes,
Hello.
sir.
Batching of concrete means measuring different ingredients before mixing it in terms of weight or volume. Yes, when this measurement is done on the basis of volume, we call it as volume batching. Okay, so you tell me one thing. Did you have you got the subject concrete technology in the in the previous semesters?
No, sir. No, sir.
No, sir.
No.
No.
So where you have studied about concrete? In which semester?
In previous semester, we studied
You speak little bit loudly.
material testing and evaluation.
In third sem or fourth sem, you have studied concrete.
Fourth sem,
Fourth sem. Okay, okay. So what are the thing? What are the other things you have studied about concrete? Only what definition of concrete or any other things?
types of concrete,
Types of concrete. Okay, so what are the types of concrete?
mm,
PCC.
no,
And then lightweight concrete.
Hmm. And okay, so in this subject, the types of concrete and all definition, you won't get these things. Okay, you won't get these things in this subject. In this subject, you have to study about the design of various components of RCC structures. Okay, like if you are designing a building, means how we can design the beams, how we can design the columns, how we can design the foundations. These things you have to study briefly in this semester. Okay.
Okay, sir.
Okay. So in the last class I told you that you have to, I will tell you about the books, which books you have to refer in this semester. I will tell you. No, I told you last in the last class. Is it? So
Yes,
this
sir.
semester everyone must buy at least one book on design of reinforced concrete structure. Everyone, at least one book on design of reinforced concrete structures. Can you hear my voice? All of you, can you hear me?
Yes, sir.
Okay.
Yes, sir.
So okay, so I can show you one book now. Okay, you can, as you can you see this book?
Yes, sir.
Yeah, it is design of reinforced concrete structures by S. Ramamrutham. You can buy this book also. Okay, I can write the this one. What writer name? Ramam Rutham. This is the name of the writer, Ramamrutham. Okay, and the book name is Design of Reinforced Design of Reinforced Concrete Structures. Yes, by Ramamrutham. Okay, you have other books also. Okay, you can buy lot of books. You will get. Okay, so many books are there on this topic, design of reinforced concrete structures. But this Ramamrutham is quite good. You will get so many more examples here.
Sir,
Yes.
uh, you gave us the definition of volume pitching now.
Yes, yes, yes.
After that, did you give any notes? Because I missed out because of network.
No, it is written in the chat box. You can see the chat box. Whatever I have told you, it is all the things are written in chat box. Batching of concrete means measuring different ingredients of concrete. This part is written in chat box. I think Huketo Achumi wrote these things.
Yeah, I wrote.
Yeah, yeah, yeah.
I wrote,
See the
but
chat box. Okay, so you can buy this book also, or buy writer this book also, Neelam Singh, or S S maybe.
Let me get the syllabus also.
Yeah, you can. Yeah, any book you can buy. Okay, either S Ramamrutham or writer Neelam Singh or S Bhabikati. Anyone. Okay, but at least you have to buy one book.
Okay, sir.
Okay, because this time the physical you can't come physically, no. So if you have a book with you, then it will be very helpful for you.
sir, so which one are you using? Like, which one are you referring in out of these three authors?
No, no.
Yes, sir.
Anyone you can buy. Anyone. These three
Okay.
writers are the best in this topic. Okay. Design of RCC concrete structures. You will get in on design of this RCC. You will have lot of books by different authors. But these three authors, you will find it. These are the three best books. Okay. So I am saying that you can buy at least one. You can buy three of them also. Okay. No issue. You can buy all of them, but at least everyone you must buy one. At least one. At least one book you must buy for this subject. Okay. Okay. So next, since in this subject we will be basically dealing with RCC. RCC means reinforced cement concrete. Okay, so why it is called reinforced cement concrete? Why? Why it is called reinforced cement concrete? Can anyone tell me why it is known as reinforced cement concrete?
Sir,
Yes.
uh, I think I forgot, but I think RCC means like the mixture of cement, concrete, aggregate, plus steel.
Yes, plus steel, because steel is inserted in
Yeah,
this kind of concrete, is it? That's why it's known
yeah,
as RC
reinforcement.
concrete. Means reinforced means steel. Okay, it is reinforcing with steel. Okay, so now can you tell me why steel is used? Why not any other material and why steel only? We could
Sir, to
aluminum also. Huh?
reduce the tension.
Because
To reduce the tension.
to reduce the tension. Okay. So is there any other reason? Any other reason? Yeah, this is one.
Sir, the elasticity of steel is greater than other iron material.
Yeah, that is a property of steel, but because of that property, it is not used. We have to use a ductile material. Okay, we have to use one ductile material to reduce the tension, and steel is one. That is one reason. Can you tell me the second reason? Can anyone tell me the second reason? And I will give you 2 marks.
Can be easily welded.
2 marks bonus.
It can be easily welded.
No. For giving me the correct second answer, I will give you 2 marks bonus in sessional.
Sir, it can be molded into different shapes.
That is known as ductile. That is the property of a metal. It can be reshaped into any shape. That is the property of a metal. But because of that property, it is not used.
Sir, reduce
Sir,
corrosion.
Yeah.
Reduce corrosion.
No.
Tensile strength.
No.
Provide tensile strength.
What? For?
To provide tensile strength.
I can't. Can you write down the reason? Can you write down? I can't because your voice is not clear.
To provide tensile strength.
Yeah. That is one reason. I am saying that is one reason. Yes, that is one reason. But can anyone tell me what is the second most important reason? Second most important reason.
Sir, it can be magnetized permanently.
No, if it is magnetized, then steel is a metal, so it can be magnetized only. But because of that reason, it is not used.
sir, I think like steel can withstand a high strength of concrete.
Yeah, that's already said by Shiroda already, and there is one reason. I am saying the second reason. Can anyone tell me one? You have 1 minute to get the extra 2 mark. Just tell me. Otherwise, I'll tell you the reason.
It because it carries like it can carry stress
It can
and
carry.
stress, like the stress.
Why you are saying the same answer in different language word? Your answer is same, but in different words. Because its nature is brittle. No, it is not a brittle material. It is a ductile material. You can't break steel so easily. It's wrong. Okay, so can you write down the answer? Anyone? You have 1 minute. It is linear elastic material and widely available and cheapy because it's cheaper than other. No. Any other reason? Resisting tensile strength. Yeah, this is. I have already got this answer before. It bonds well to it gives strength to the concrete. No.
Sir,
Yeah.
I think it can be easily deformation.
Yeah, that is the property of a metal. Is the property of a metal. It does not rust. No, it is not a reason. Steel is used because it bonds well with concrete and expands and contracts. Okay, yes. Who wrote this one? Oinam Nivea. Oinam Nivea. Yeah. You have got the correct answer. What is your enrollment number, Oinam?
12.
Okay, very good. Very good. Yeah, you see the answer. Okay, you can see the chat box. You can see chat box. See the answer written by Oinam Nivea. Steel is used because it bonds well with concrete and expands and contracts due to temperature at similar rates. Yes, very good. This is the reason of using concrete in or using steel in concrete. Okay, because if temperature changes, if you use any other material, okay, so if that material expands more than concrete, then what will happen? It tries to come out of concrete, is it? And in that case, what will happen? Your cracks may occur in the surface of the concrete. Or if the temperature reduces, then what will happen? It will contract. And if the contraction is not same with concrete, then what will happen again? It will contract more. Is it? So in that case also your concrete can fail. Okay?
So then what is the use of using steel in this one?
Because steel expands and contracts at similar rates, at same temperature. Say at same temperature, you can see the answer. That is the most important reason. Okay. Steel contracts and expands similarly with concrete at different temperatures. That is the second most important reason. Okay, so there are two reasons for using steel in concrete. First reason is to reduce the tensile stress, and the second reason is this reason. Concrete expands and contract due to temperature at similar rates with concrete. Okay, this is the second reason. So two reasons. Okay, and this is one of the most asked questions in your viva. Okay, when you will be appearing in your industrial viva, this is one of the most common questions that the external will ask. Okay, so you have to remember the second reason. Everyone knows the first reason, to reduce the tensile stress. Okay, but most of the students forgot this answer, the second reason. Okay, so all of you remember both the reasons, because of these two reasons only we always use steel in concrete. Okay, so now what are the types of aggregate? What are the types of aggregate?
Fine aggregate and coarse aggregate.
Okay, so how can you classify fine aggregate and coarse aggregate?
Fine aggregate which can pass the ISC of 480.
4
480.
480? No, it's not 480.
So I forgot.
Yeah, can anyone tell me how can you classify fine aggregate and coarse aggregate? No one can answer me. Okay, so you can write down. If the size of aggregate is less than 4.75 millimeter, yeah, fine aggregate can pass ISC 4.75. Yes. If the size of aggregate is less than 4.75 millimeter, then it will be known as fine aggregate. And if the size is more than 4.75 millimeter, then it will be known as coarse aggregate. Okay, so next, can you tell me can you tell me some grades of steel? Different grades of steel. Can anyone tell me some grades of steel? Different grades of steel. Yeah, mild steel, high carbon steel, yes. Is there any other grade? High tension steel, tensile steel. Okay. So I am asking grades. That means this must have some value. Can you write down that values? Means if you say alloy steel. Okay, so I got this. You are writing the names. Okay, so can you write down the grades? Means just like if you consider concrete, you can see different grades of concrete are there. M10, M15, M20, M25, M30, like that. So steel also have some grades of steel. So can you write down those grades? At least 3. Can you write down at least 3? Okay, so you haven't learned. Okay. So I am writing in the chat box. You can see that. Okay. Fe250. It is also known as mild steel. then Fe 415 and Fe 500 and Fe 500. Therefore, HYSB.
Sir,
Yes,
what is the term Fe means? What does Fe stands for?
HYSD I have written it. High yield strength reform bars.
Fe like Fe 250.
Fe for
What does
iron,
that
iron.
mean?
Steel is nothing
Iron.
but
Okay.
one grade of iron, no?
Okay, sir.
Steel is nothing but the grade of iron. Fe means iron. So, in any question, if you
Sir, like it's
yes,
sir, like it's Fe 250, right? Like Fe
uh,
250. So what? Sir, like you have written in that box Fe 250, right? Like Fe 250.
Fe 250, it is a grade. Just like concrete, we have different grades of concrete, na? M10, M15, M20, like that. So these are the different grades of steel, or
Okay, okay,
these are the different classes of steel.
okay. Thank you, sir.
Okay, so this session will end within 5 minutes. Okay, so I will give you another link. You can join in again.
Sir, how are the grades classified? Like,
Based on the strength, these values, na, 250, 400, 415, 500, these are nothing but the strength of steel. Strength means,
acha.
yeah, this is known as yield strength. Yield strength means this 250, na, this 250 value is in terms of Newton per millimeter square. 415 means the strength is 415 Newton per millimeter square, and 500 means 500 Newton per millimeter square.
Okay, sir.
Okay, so based on the values, it is classified. Based on the values of yield strength, these are classified. Okay, so in this subject, we will be basically dealing with these three grades only. Okay, Fe 250 or mild steel and HYSD bars. Whatever problems you will get, all the problems you will see any one grade, either 250 or 405, 400, 515 or 500. Okay, so can you tell me what are the different grades of concrete? At least 5 grades. Can you tell me 5 grades? 5 grade of concrete. 5 different grades of concrete. Hello. Okay, M20 and
Sir, M10.
M10. Okay, 5. I am asking you.
M10.
Yes. Okay, so okay. No need to write down again. So can anyone tell me what is the proportion of M25 grade of concrete? M25. M25. Okay, good. 1:1:2.